So, for each graph, we want to sketch the graph of the square root of f of x. Step one, and the stuff that we highlighted so neatly, was that wherever the points of the original graph are 0 and 1, 0, 0, let's go to 1, find those points are not going to change. Step two, anytime your y values are between 0 and 1, your radical function is going to be slightly above. This is a tough one to draw slightly above because this is bad. I'll draw it in bed. That would be bad because you went back in time. It shows slightly above, but it's bad going back in time. In this one, you'd almost draw it right on top because you can't go back in time. Because it has to be above the original function. Because if you took the square root of something between 0 and 1, say I take 0.64, the square root of 0.64 is 0.8, and 0.8 is slightly higher than 0.64. Then step three, any places where your y values were bigger than 1 on your original graph, your square root graph will be lower. And step four, any places where your y values are negative, like in this section, your square root graph won't exist because you can't take the square root of a negative. So notice we will not draw anything between those 2 points. And the blue graph is the sketch once we're done. So what we have for a domain, now our domain says that x can be less than or equal to 1, or x can be bigger than or equal to 5. And our range, our y values are bigger than or equal to 0. This time I didn't do any other nice points, but if you wanted to, can you see that your y value is 4 right about there? So I could have made my y value on my blue graph 2 at that same x coordinate, even though I don't know what that x coordinate is. So you can use that to help. I guess here I did a bad job. I should have had the blue point there. In the second one, again, step one, find out all the points that are going to stay the same, which are at 0 and 1. Then between 0 and 1, it's going to be slightly above. And this one really is hard to show that. Then after, your y values are going to be less than 1. But we can have some values here, like what's the square root of 9? 3. So we know that that point's going to go there. And there, my entire graph is less than my red graph. Of course, where the red graph is negative, your square root graph won't exist. So domain on this one, and range. Of course, you could write this in interval notation as well. Either would be fine. On B, why do I connect my points? Keep going up. Since the biggest value here, positive value is 9, when I square root 9, I get 3. If I would think of other points, like I could take this point where it's 4, the square root of 4 would be 2. Same thing over here. I have 4, square root of 4 is 2. Does it make sense that the biggest value on my blue graph is going to correspond with the maximum on my red graph? Because you're square rooting something. So the biggest it'll ever get, when you square root it, will also be the largest it'll ever get.
So what if you have
You would just guess, yes. Like if it went up to 15, you would say square root of 15 is just a little bit less than 4, and you would estimate where that would be. And notice on the first graph, the original graph just kept going up forever. So my square root graph has an arrowhead as well and keeps getting bigger forever as well. Okay, question number 8 for practice.